Okay, so now that we've talked about some of the common patterns we see in use today in enterprise, let's talk a little bit about how Service Mesh attempts to address some of these issues, and we'll go through the traditional Service Mesh with Sidecar, and then I'll talk about Ambient Mesh. So again, we have our applications, A and B. And in the Sidecar model, what we do is we attach a proxy to each of the unit of the applications, right? And this proxy can do MTLS, it can do routing, let's say HTTP routing, and it has observability built into it. So let's say OpenTelemetry. And we program these proxies to capture all the traffic coming in into out of these units of application, and all of the traffic will flow through this path. So comparing to the hairpinning solution, for instance, there's no big centralized point of failure because there's literally a proxy for every application deployed in the network. That also means that we've solved the latency issues associated with hairpinning, and because these are owned by the individual units of the application, for the application teams, it's actually safe to let them write policies that will be implemented by these proxies, right? So we don't have ticket ops. We can have APIs that the application owners can use to control the behavior of these proxies. So the system has become much more adaptable. Right, and that's one of the big advantages of Service Mesh, is designing the system so that the units of infrastructure are aligned with the use cases and the roles in the organization so that they can compose. So application teams can write policies and admins can write policies, and those policies are merged together to create an effective system. The other advantage is in the hybrid world, like we showed before, we do exactly the same thing. Right, so let's say this is your on-cloud environment. There's an application C over here. It also has a proxy, and when B wants to talk to C, they go through each other. And we talk about how we bridge these networks, right, with an east-west gateway to allow connectivity. So we've also solved the kind of hybrid environment problem because we can make sure the same policies, the same load balancing, the same set of capabilities that we have over here work here too, and we can use the same policies and the policy database effectively, or usually it's checked into Git, to control the behavior of this system. And if C happens to move into this environment, the policy doesn't have to change, right? So the hybrid environment or the topology of the system can change almost at will, and yet none of the policies have to change. And right, because we're using MTLS to represent the identity of these applications, right, we're not tied to the kind of infrastructural ideas of identity like IP address, and can rely on identity staying stable even if a piece of application moves into another environment. So a good example of this is, let's say C is a VM and we're running the sidecar on a VM, and then I decide I package C into a container and I run it now in Kubernetes. Nothing changed. All the policies stayed exactly the same. Right? So the system and the policies become immutable to the underlying infrastructure, right? Which is for some major benefits. And this is kind of the fundamental design of what service meshes are designed to do at the policy layer, right? They're designed to hide from you the infrastructural artifacts, whether IP address or locality, from the behavior of the system in the network and how applications talk to each other, right? This is the primary benefit of service mesh. But there are some downsides to the sidecar model, right? These proxies have to have a lot of capability built into them, right? So they're L3 and L7 capabilities. They have to be able to implement all the policies that we want to express. And because we have to have them on both sides, right? Because I want to do routing on the outbound side, and I need to do, let's say, authorization and authentication enforcement on the inbound side, that capability has to exist in both paths for a single communication flow. That means these proxies have to be quite capable, and right, what we've done in Istio in the Glue Mesh product is we use Envoy for this. That also means we have to load a fair amount of policy into each one of these things, and if the network is large, these need a view of the topology of the network to be able to enable communication, which means they need to see quite a lot of state about the available services and endpoints in the network, which means that there's quite a lot of configuration being pushed into these proxies. And we're doing that at scale, so there may be thousands, tens of thousands of these things. The control plane is pushing that configuration out, and that can represent a fairly large resource burden on the infrastructure. The other, probably most obvious problem is because they are tied together, if I need to update this, I have to roll out an update to this as well at the same time, right? they have shared lifecycle. And so let's say there's a patch we need to roll out to Envoy. That means that every application in the system needs to go through a rolling update. For many organizations, that's fine, right? They have a policy posture where they say, I'm fine, my applications must receive a new update once every month. But there are a very, very large number of organizations today where they cannot absorb that frequency of update. I may build this system once every 3 months. I've run into examples in customers where I see instances of these types of systems where the application has stayed up for over a year. And so the less like cattle your applications are and the more like a pet they are, the less maintainable this solution becomes. It also, because it blurs the boundary between infrastructure, which is what the sidecar is, and the application, the responsibilities in terms of the various roles in the organization also become blurred, right? And so the application owners don't want to update their application unless the application, the logic that they built into it requires an update. And the platform team doesn't want to have to coordinate with the application teams every time they want to maintain the infrastructure, right? And that coupling creates friction. And that can often slow down maintenance or prevent maintenance from occurring. And so the sidecar model solves a lot of the problems in the other architectures we talked about, but it also has its own set of issues.